In this lesson, we'll be looking at how to graph and solve inequalities. And this video specifically will be the first part of this. We'll look at how to take inequalities and graph them onto a number line. But you might be asking, what is an inequality? Well, an inequality is something that is unequal. So often you've probably seen back to elementary school, greater than signs, less than signs, and equal signs. We're going to essentially be looking at things that are like equations, but instead of equal signs, they have either greater than signs, less than signs, greater than or equal to signs, or less than or equal to signs. Remember always that the sign opens up to the bigger side. So if we take a look at an example of what kind of problem this says graph x is greater than 1. Now when we say graph, we might think of a big coordinate grid and find the x and the y. Here graphing means graph x on the number line. And they tell us x is greater than or equal to 1. So how we would graph this is, first, we want to look at what this is. This says that x can be greater than or it can be equal to 1. So what we're going to do at the number 1 is put a solid dot saying that x can equal 1. Then think about x greater than 1. What numbers are greater than 1? 2 could be greater than 1. 3 could be greater than 1, and anything going up from that. On our number line, that's shown by going to the right. Bigger numbers, 2, 3, 4, 5, 6, and so on, are to the right. So how we graph that x can be anything bigger than 1 is we just put an arrow going to the right. And it starts at that solid line. So this says the solution is x is equal to 1 or bigger than 1, but it can't be smaller than 1. So the next one here says graph x is less than 3. Now x less than 3. Here we don't have an equal sign. So that means x can't be 3, but it can be something less than 3. So it could be 2. But 2, it doesn't mean 2 is the start of it. It could also be 2.9. 2.9 is less than 3. 2.99 is less than 3, and so on. So what we do is we still put a dot at the number 3, but we put an open dot, meaning it can't equal 3, but it's going to equal everything very close to 3. And since we're talking about numbers that are less than 3, we're looking to the left. So we take that open dot and put an arrow going left, and that's our solution. This is saying x is everything less than 3, except for the number 3 exactly. So when there is an equals, we do a closed dot. When there is no equals, we do an open dot. And so the other thing we're going to look at is compound inequalities. What happens when there's more than one inequality? Well, this says we're going to graph x is less than or equal to -3 or x is greater than 1. What this tells us is there's going to be this or, and the two inequalities tells us there's going to be two different arrows going different directions. First, let's look at the first inequality. This says x is less than or equal to -3. So we put a dot at -3. It's equal to, so we can fill it in. And x is less than that number, so that is going to the left. But in this case, this is only half our solution because the solution x can also be, or x can be greater than 1. So we put a dot at 1. This one does not have an equals, so we'll leave this an open dot. And if x is greater than 1, we can go to the right. So this is what happens when we have an or. It means that we'll have two inequalities, usually going opposite directions. And we also want to watch what kind of open or closed dot do we have. The last one we have, a compound inequality. This literally says a graph negative 2 is less than x is less than or equal to x is less than or equal to 5. Now that's a lot to go on, so let's break this down. First, let's look at what this says. This says negative 2 is less than or equal to x. If we flip this around, this says x is greater than or equal to negative 2. So we can put it's equal, a dot at negative 2, and we know we're going to go right, but we're not going to finish the arrow yet because we're also told x is less than or equal to negative or positive 5. So if we write that, this says x is less than or equal to 5. Again, a closed dot, but at 5, and less than tells us we're going left. So what happens is, if we connect this all, x is anything between negative 2 and 5. This graph would be our solution. And anytime we see an inequality like this with a number, an x, and a number, what this is saying is x is between these two numbers, or potentially equal to. Another way this could be written is x is greater than or equal to negative 2 and x is less than or equal to 5. So it's different than the one above where we had or going opposite directions. These are both happening at the same time. It's between two numbers. And that's how we graph that. So to review, make sure, watch whether it's a greater than, less than sign, or if there's an equal in it. If there's equals, we would do a closed dot. If it's a open dot, we do, or if it's a not equal, we do an open dot. And we want to make sure we're going the correct direction. So if x is larger than the number, we go right. If x is smaller or less than the number, we go left. And if we have compound, we draw each one. And if they're going opposite directions, they go out forever. And if they go towards each other, the dots will be the endpoints. So go on to the next video on solving inequalities, which is similar to solving equations, and then you can practice this and solving inequalities in the practice assignment and then try the assessment.